Hello and welcome to another IB chemistry video with Mr. S. In part A, we were looking at how the ionization energy increases across a period because the nuclear charge increases and there's no extra shielding effect. However, there's two exceptions to this trend of increase across a period. Let's have a look at that. And it has to do with how the electrons are filled in the different orbitals. So if we take a look at magnesium and aluminium, magnesium in group 2 and aluminium in group 3. This exception we will see when we transition from group 2 to group 3 elements, no matter which period we are talking about. Now, magnesium has an electron configuration of 1s2, 2s2, 2p6, 3s2. Aluminium has the last electron in a p orbital, 3p1. Now, why does that matter? Well, as you know, an electron in a 3p orbital is at a higher energy level, and therefore it is easier to remove it. As a result, there is a little dip in ionization energy between magnesium and aluminium. It is lower for aluminium than magnesium, although the general trend is that it is higher across a period. So less energy is required to remove an electron from a p orbital than an s orbital. This will happen in any period. Now, there is also an exception between group 5 and 6, so looking at phosphorus and sulfur. So phosphorus has the last orbital here, 3p3, whereas sulfur is 3p4. Why does that matter? Well, there are three orbitals, p orbitals. In phosphorus, they're each singly filled, whereas in sulfur, one of them is going to be doubly filled as such. Now, because in this orbital you have got two electrons, they repel each other because they have the same charge. And therefore, removing an electron, removing one of these electrons, is actually energetically favorable. So you require less energy to remove that paired electron in the p orbital. So again, there's a little dip between phosphorus and sulfur. So sulfur has a lower ionization energy than phosphorus, although you would expect the opposite because you're going across a period again. So those are the two exceptions that you will find in these groups. One of them has to do with which orbital the electron occupies. Is it an s or a p orbital? And the other exception is because of a doubly filled orbital. Thank you very much for listening. Hope this has helped.